Everyone knows Earth has one moon, right? But what if I told you that astronomers have discovered another object orbiting with us, often called Earth's second moon? It doesn't behave like the moon we see in the sky. Instead, it dances around our planet in a mysterious orbit. This strange companion is what scientists call a quasi-moon, and its existence could change the way we think about Earth's place in the solar system. A quasi-moon isn't a permanent satellite like the moon. Instead, it's an asteroid that shares Earth's orbit around the Sun. From our perspective, it looks like it's looping around Earth, but in reality, it's being pulled by both the Sun and Earth's gravity in a delicate balance. Think of it as a cosmic dance partner, never straying too far, but never fully bound to Earth either. For all of human history, we've looked up at a single constant companion, the moon. It has shaped our calendars, our myths, and our tides. We thought we knew our celestial neighbourhood, but it turns out Earth has more than one fellow traveller. They're just much, much harder to spot. The most famous of these hidden companions is called 469219 Kamo'olawa. It was discovered in 2016 using the Pan-STARRS telescope in Hawaii, which constantly scans the skies for near-Earth objects. But astronomers found something different, a constant tiny shadow tagging along with our planet. So, what exactly is it? Kamo'olawa is a quasi-moon. Unlike our moon, it doesn't actually orbit the Earth. Instead, it orbits the Sun. But its orbital path is so similar to ours that it stays close by. Imagine two race cars on a vast circular track in adjacent lanes. From our perspective on Earth, Kamo'olawa appears to be spiralling around us in a bizarre corkscrew-like dance. Its name, Kamo'olawa, is a Hawaiian word that beautifully describes this motion, meaning the oscillating celestial fragment, and it is a fragment, a tiny one. At only about 40 to 100 meters across, it's no bigger than a Ferris wheel. For centuries, this small space rock has been playing this game of cosmic tag with Earth, and it could continue for centuries more. But here's where the story gets truly mind-bending. Scientists studying its reflected light discovered that its composition is remarkably similar to rocks on our own moon. The leading theory is that Kamo'olawa is actually a piece of the moon, blasted off by an ancient asteroid impact and sent into its own unique orbit around the Sun. It's a lost piece of our own celestial backyard, hiding in plain sight. This potential origin makes Kamo'olawa an incredibly tempting target for space exploration. It's one of the most stable quasi-satellites known, and its Earth-like orbit makes it relatively easy to reach. In fact, China's planned Tianwen-2 mission aims to visit Kamo'olawa and collect samples. It would be a historic achievement, retrieving a piece of our moon without ever having to land there and unlocking the secrets of this mysterious spiralling companion. Astronomers believe studying quasi-moons could reveal secrets about the solar system's history. Some think Kamo'olawa might even be a fragment of our own moon, knocked loose by a massive impact long ago. Others believe these objects are captured asteroids, leftovers from the solar system's violent beginnings. And because they stay relatively close to Earth, they could one day serve as stepping stones for space exploration or even asteroid mining. But here's where the story gets more mysterious. Quasi-moons like Kamo'olawa aren't easy to track. They are cosmic ghosts, tiny and dark, making them faint targets for our telescopes. For decades, we didn't even know they existed. These objects aren't truly bound to Earth. Instead, they are fellow travelers, caught in a complex gravitational dance as they orbit the Sun on a path remarkably similar to our own. Their orbits shift unpredictably. While our moon circles the Earth, a quasi-moon is primarily orbiting the Sun. Earth's gravity just gives it a constant nudge, forcing it into a strange corkscrew-like path relative to our planet. It slowly drifts ahead, then falls behind, in a delicate balance that is easily disturbed. These gravitational tugs make long-term predictions a massive computational challenge. It's a celestial ballet governed by the laws of chaos, where a tiny change today could mean a completely different orbit centuries from now. This inherent unpredictability is a source of both fascination and concern. Some astronomers warn that these objects could, in the distant future, pose a collision risk if their paths change. The strangeness of its orbit also led to wild speculation. Could it be an artificial object, a forgotten rocket booster, or perhaps something more exotic? Others wondered if they could be mistaken for strange visitors lurking near Earth, as its orbit seemed almost engineered. But then, a crucial clue emerged. Spectroscopic analysis revealed its light signature was a near-perfect match for weathered rock from the surface of our own moon. This has led to a stunning hypothesis. Kamo-Walewa might be a lost fragment of the moon, blasted into its own solar orbit by a colossal ancient impact. To find out for sure, China's Tianwen-2 mission is planning to visit, land, and return a sample. Imagine, a second moon that isn't really a moon at all, but a long-lost piece of home holding secrets to our own planet's violent past. Kamo-Walewa isn't alone. Earth has had other quasi-moons in the past. For example, 2006 RH-120 briefly orbited Earth from 2006 to 2007 before drifting away. These companions come and go, appearing for a few years, then disappearing back into space. This means Earth may not just have one moon, but many temporary moons throughout history. China's space agency has already announced plans to send a probe to Kamo-Walewa in the coming years. If successful, it will be the first mission to explore a quasi-moon up close. Scientists hope to learn its origin, composition, and whether it truly came from our own moon. This mission could provide answers, or raise even more questions about Earth's mysterious companions. So, does Earth really have a second moon? The answer is a fascinating not exactly. While we don't have another large, permanent satellite like our familiar moon, we are accompanied by a handful of quasi-moons. These aren't moons in the traditional sense. They don't orbit the Earth. Instead, they orbit the Sun on a path so similar to our own that from our perspective, they appear to be our constant companions, tracing a slow, looping path around our planet. Think of it like two cars on a racetrack in adjacent lanes, with one occasionally pulling slightly ahead or falling slightly behind. They are gravitationally tethered to the Sun-Earth system, but not to Earth alone. This complex orbital dance is why they remained hidden in plain sight for so long, cosmic companions we barely noticed. The most famous of these is Kamo-Walewa, discovered in 2016. It's tiny, no bigger than a Ferris wheel, and its orbit will only keep it near Earth for a few more centuries before it drifts away. But what makes it truly special is its composition. Analysis of the light it reflects suggests it's made of silicate rock, very similar to material found on our own moon. The leading theory, a truly mind-bending one, is that Kamo-Walewa could be an ancient fragment of the moon itself, blasted into space by a powerful asteroid impact millions of years ago. It's a piece of our own celestial history circling us in disguise. This possibility has ignited the curiosity of scientists worldwide. For millennia, humanity has looked to the moon for inspiration, for navigation, and for myth. It's a cultural touchstone. Yet, these quasi-moons, potential children of the moon, have been silently orbiting nearby, completely unnoticed. But that's about to change. China's upcoming Tianwen-2 mission is slated to visit Kamo-Walewa, land, and return a sample to Earth. This will be a pivotal moment. If it is a piece of the moon, it will give us an unprecedented, relatively easy-to-access sample of lunar geology from a location we've never explored. If it's not, it will still tell us a great deal about the population of near-Earth asteroids that share our orbital space. These quasi-moons are more than just astronomical curiosities. They are time capsules, potential stepping stones for future exploration, and a profound reminder that our solar system is a dynamic and ever-changing place. The story of our planet and its companions is far more complex and intricate than we ever imagined. The real question is, what secrets are they keeping, and what will we discover when we finally reach out and touch them? What do you believe Kamo-Walewa is? A long-lost piece of our own moon, a captured asteroid from the dawn of the solar system, or something else entirely? Let me know your theories in the comments below.